Hello friends, welcome to NEET World. Good evening. So, this is your Abhilash sir, Mathematics faculty for EAP set, KSET, JEE and also Foundation. So, we will be continuing our session when it comes to class 10 CBSE Mathematics, and also we will be covering state board. In the previous class, we started off with polynomials where we gave some introduction. So, mainly we discussed what is a constant, then we discussed what is a variable, and then we learnt what is an algebraic expression. That is where we combine both constant and also variable through some mathematical operation, be it addition, subtraction, multiplication or division. Through algebraic expression, we also derived what is a polynomial. So, polynomial is a combination of constant and variable where the variable can be raised to any power, be it 0, 1, okay, 2, like that. Then we learnt a general form of a polynomial, that is a naught. What is that we learnt? We learnt what is general form of a polynomial, that is nothing but we learnt a naught plus a1 x1 or something like a2 x square, a3 x cube plus a4 x4 up to an x to the power of n. This is the general form of polynomial we learnt. Then also we learnt what is value of a polynomial. We learnt what? Next we learnt what is value of a polynomial. Value of a polynomial we learnt. Just I am revising. For those students who have not attended the previous class, kindly attend the previous class and then attend this class. It will be very useful for you. Okay. Next, then we learn what is the value of a polynomial. Suppose a polynomial in p of x is given. If I put p of x is equal to given x square plus 2x, something like this. If I put some value for x, if I get whatever the value, okay, whatever the value I get, suppose I put x is equal to 1 here, okay, I will get what? This will be equal to p of 1 will be equal to what? 1 plus 2, that is I will get it as 3. So, this 3 is called value of the polynomial at which point? At point x is equal to 1. This is the meaning of value of the polynomial. Then we learnt what? Then we learnt something called zero of the polynomial. Zeros of the polynomial. Zeros of polynomial we learnt. That is, when I get, suppose I get p of x is equal to given as x square minus 2x, okay, minus 2x minus 3 is given. This is the polynomial. Suppose I put x is equal to 3. If I put x is equal to 3, what I get? This will be 3 square is 9, 2 3 is 6 minus 3. This will be 9 minus 9. I will get is equal to 0. This 0 is nothing but what? Value of the polynomial. When the value of the polynomial becomes 0, for at which point? When x is equal to 3. This x is equal to 3. This x is equal to 3 is called what? Okay, this x is equal to 3 is called what? 0 of the polynomial, because this 0 of the polynomial, because this x is equal to 3 is making the polynomial equated to 0. That is, we are getting the value of the polynomial as 0 when we put x is equal to 3. This x is equal to 3 is called what? 0 of the polynomial. And then we learn types of polynomial based on terms. If there is a single term, it is called monomial. If it is two terms, then it is called binomial. If it is having three terms, it is called trinomial. And similarly, if it is having any number of terms, we call it as polynomial. Then we learn something very important, that is degree of a polynomial. Then we learn something very important, that is degree of a polynomial. Degree of a polynomial. Okay, degree of a polynomial, it is nothing but value of the highest power of the variable. Value of the highest power of the variable is called degree of the polynomial, and based on degree of the polynomial, we learned various types of polynomials. What did we learn? We learned various types of polynomial. That is, one of the type is called linear polynomial. Another one is called quadratic polynomial. Then we learned what is cubic polynomial. Then we learned what is biquadratic polynomial, and then we learned what is constant polynomial. Then we learned what is zero polynomial. Okay, linear polynomial where degree is equal to 1. Okay, quadratic polynomial where degree is equal to 2. Cubic polynomial where degree is equal to 3. Degree means what? Value of the highest power of the variable. And biquadratic polynomial where degree is equal to 4. And constant polynomial where degree is equal to 0. That is, if I write 5, 2, 3, something like that, where there is no variable, that can be written as 5 can be written as 5 into x to the power of 0. Their degree is what? The degree is 0. Degree is 0. Zero polynomial where 0 is the only value that is there. 0 can be written as what? 0 into x, 0 into x cube, 0 into x to the power of 4, anything. This gives me what? 0 itself. This gives me what? 0 itself. This gives me what? 0 itself. For such a polynomial where degree cannot be defined, that is, degree can keep on changing, that is called what? The degree is not defined. I read it as ND. Degree cannot be defined, that is called zero polynomial. Is it clear? So these are all the basics we learnt in the previous class. In this class, it is very important to know that very important concept is being discussed, that is called geometrical meaning of zero of a polynomial. Yesterday itself I told you what is a zero of a polynomial. Now we will understand what is the geometrical meaning of zero of a polynomial. Based on that, there is one exercise, that is exercise 2.1. What is geometrical meaning of zero of a polynomial? That we will understand now. Geometrical meaning of zero of a polynomial. Suppose we have understood that, suppose p of x is a polynomial in x if it is given as x square plus 2x plus 3. Okay. Suppose I put x is equal to k. Okay. If I put x is equal to k, this will become equal to 0. Then this k is called what? Is called zero of the polynomial. Is called what? Zero of the polynomial. Okay, this is the algebraic meaning which we understood when it comes to zero of the polynomial. This is the algebraic meaning of what? Zero of the polynomial. Now let us try to understand what is the geometrical meaning of zero of the polynomial. So when we try to understand what is the geometrical meaning, first let us consider linear polynomial. Okay, let us consider linear polynomial. Okay, linear polynomial is one, for example, linear polynomial p of x. I can write it as what? Ax plus b. Ax plus b. Okay, linear polynomial graphically if I represent, okay, if I put any value, I am get a straight line like this. Any straight line, I can get it like this or anything. I have taken this straight line. Okay, ax plus b represents what? It represents a straight line. Okay, p of x is equal to ax plus b, linear polynomial. It represents what? It represents a straight line. It represents a straight line. And also it is representing a straight line, and you have to focus on at how many points it is touching x axis. Why x axis? Because it is a polynomial in what? It is a polynomial in x. If I had given a polynomial in y, you have to focus on y axis. Okay, if I had given a polynomial in y, you have to focus on y axis. Since it is a polynomial in x, you have to focus on how many times it is touching x axis. Okay, here it is touching x axis how many times? Only one time. Okay, here it intersects. Here it intersects x axis at only one point. Okay, so at only one point. So that means what? Here it is having only one point. So it is having only 1 0. Here it is intersecting how many points? Only one point. It is having only 1 0. Okay, it is having how many zeros? It is having only 1 0. So you can say that. So you can draw a correlation. Degree of linear polynomial is what? 1. Zeros is how much? 1. So degree is 1, zeros is 1. So degree of a polynomial is 1 and 0 is 1. This is what we can say. Similarly, for quadratic polynomial, degree is 2 and the number of zeros is also 2. For cubic polynomial, degrees is 3 and the number of zeros is also at most 3. I cannot say exactly 3, it will be at most 3. Okay, I will tell you why at most. This is 3. Okay, next thing is, if the degree is 5, okay, 0 will also be 5. If the degree is n, then 0 will also be n. Like that we can say. Now, let us not worry about this. Now we learnt when it comes to linear polynomial. When it comes to linear polynomial, this is what it is. We understood. That is, it intersects at exactly one point, and it is a straight line. It is what? It is a straight line. Okay, this is what? This is a straight line. We understood. What is a straight line? The graph is a straight line, and it intersects at exactly one point. So that means what? How many zeros does it have? Only 1 0 at this point. Whatever the point we get. Suppose we get it here as 2, 0. Here 2 is what? Here 2 is the 0 of the polynomial. Here 2 is the 0 of linear polynomial. Okay, 2 is the 0 of linear polynomial. Okay, that's it. Clear? This is about linear polynomial. Now let us see for quadratic polynomial. For quadratic polynomial, see here. Quadratic polynomial. let it be in P of x itself. P of x can be written as ax square plus bx plus c, ax square plus bx plus c. Okay, let us draw a graph like this. Okay, so for P of x, ax square plus bx plus c, it represents, the graph represents what? It represents a parabola. You learn parabola in your higher classes, don't worry much. It is a parabola, that is, it is curved up, that is, it is nothing but U-shaped graph, U-shaped. Okay, it is curved upwards or downwards. Okay, it can be curved upwards or downwards depending on the polynomial. It is curved upwards or downwards, and it meets what? X axis, because again it is a polynomial in x. If it was y, we should have spoken about meeting y axis. Since it is a polynomial in x, it meets x axis at most 2 points. At most, why? Because sometimes the zeros can be equal, because you can get x is equal to 4, and 2 as 2 zeros. There it meets at exactly 1 point, but the zeros are 2, but they are equal. So that's why here it is at most 2 points, that is at most 2 points. So the graph can be like this, or the graph can be like this also, curved downwards, curved upwards. So this is what here, see, this is meeting at 1 point, here also it is meeting at 1 point, 2 points, 1 point meeting at another 1 point. So sometimes you can get it like this also, here it means what? Does it mean that zeros are only 1? No, here the zeros are 2, but it is meeting at exactly 1 point, because sometimes you get zeros equal. Suppose I have x minus 4 into x minus 4, if I have, here the zeros are what? X is equal to 4 and x is equal to 4. So here at this point 4 is a zero of the polynomial, but there are 2 zeros which are equal. At that time the graph will be meeting at only 1 point at the x axis. The curve will meet the x axis at only 1 point, but here the zeros are 2. But what do we say? Here the degree will also be 2, but here the zeros will also be 2, but it is meeting x axis at only 1 point. At that time we say that the zeros are 2 and they are what? And they are equal. Okay. This we will learn even in quadratic equation. B square minus 4ac is equal to 0. That time you will get real roots and also equal roots. Now let us see for cubic polynomial. Cubic polynomial, P of x can be written as ax cube plus bx square plus cx plus d. Okay, here the graph intersects x axis at most 3 points. I am not telling exactly, I am telling at most, because it may not intersect also. It may intersect at 1 point, or it may intersect at 2 points, or it may intersect at 3 points. At most 3 points. So see here, I can write it like this. See here, this is a cubic polynomial. Okay, here it may not intersect also, so it can be 0, or it may intersect like this. Like this, it may intersect at 1 point. Another thing can be, it may intersect at 2 points. Okay, it is intersecting at 2 points, this point and this point, and it may intersect at 3 points, that is 3 points here. This is 1 point, this is 1 point, and this is 1 point. It is 3 points, maximum 3 points, minimum it can be 0, 1, 2, 3. So it may intersect at most 3 points, that is cubic polynomial. This is when it comes to zeros of the polynomial. I hope it is clear. This is the basic understanding you must have when it comes to zeros of the polynomial. I hope it is clear. Now when we talk about zeros of the polynomial, this is what you understood. Next you have to understand that it has to cut the x axis to know that there is a 0 or not. If it is not cutting the x axis, that there is no 0, because you have to understand that if the polynomial in x, then the curve should cut the x axis. If it is not cutting the x axis, then it is not having a 0. If it is a polynomial in y, you have to think that it has to cut the y axis. It has to cut what? It has to cut y axis. That means it has to cut y axis if it is a polynomial in y. If it is polynomial in x, it has to cut x axis. Now based on this, there is an exercise, that is exercise 2.1. Exercise 2.1. So let us solve some questions based on this. Now they are asking class 10 maths. So the graph of y is equal to p of x are given below. This is p of x. This is what, friends? This is given as p of x. This is p of x, that is polynomial in x. Given below for some of the polynomials p of x. Find the number of zeros of in each of the case. So how many times it touches x axis? Those many zeros. If it is touching 3 times, 3 zeros. If it is touching 0 time, if it is, then that is zeros of the polynomials is 0. Here, see here, the graph is, this is the graph, it is not touching x axis at any point. Here the number of zeros is 0 itself. Here the number of zeros is 0 itself. Look at this in the second question. Here it is touching x axis how many points? Don't worry about any other axis. It is touching x axis at only 1 point. Here the number of zeros is how much? 1. Okay, it is touching at 1 point, it is the number of zeros is 1. Here look at this, in this question it is cutting the x axis at how many points? It is cutting the x axis at how many points? 1, 2 and 3. So the number of zeros is how much? The number of zeros is 3. Okay, these are all what? Number of zeros. Number of zeros. Okay, these are all the number of zeros. This is the geometrical representation of zeros of the polynomial. Here it is cutting at no point, that is why here the number of zeros is 0. Here it is cutting at 1 point, so that is why it is the number of zeros is 1. Here it is cutting at 3 points, here that is why it is the number of zeros is 3. Okay, that is why here the number of zeros is 3. Now let us have a look at it, this one. See here, let us have a look at this one. So if they are given like this, if they are given like this, here it is touching at how many points? Here it is touching at 1 point, here it is touching at another point. Here the number of zeros is how many, friends? Here the number of zeros is 2. Now have a look at this. Here it is touching at 1 point, 2 point, 3 point. Should I take this? No, it is touching y axis. I should take only x axis. 1, 2, 3 and 4. Here the number of zeros is how many, friends? It is 4. It is 4. Here the number of zeros is 4. Now if I look at this question, here the number of zeros is how much? You have to see how many times it is touching x axis. So this is 1. Okay, just a minute. This is 1 point, this is 2 point, second point, this is third point. Here the number of zeros is how much? Here the number of zeros is 3. Here the number of zeros is 3. That's all about exercise 2.1. That's all about exercise 2.1. So this is the concept you have to understand when it comes to geometrical meaning of the zeros of the polynomial. In the next exercise, that is exercise 2.2, we will be doing it in the next class, but I want to give you some introduction when it comes to exercise 2.2. In the exercise 2.2, you learn the relation between zeros and coefficients of the polynomial. You learn the relation between coefficient and zeros of polynomial. We will learn the relationship between coefficients and zeros of the polynomial. Suppose a polynomial is given. P of x is given, that is ax square plus bx plus c is given. Okay, this is a polynomial. Let the zeros of this polynomial be. Let the zeros of the polynomial be let the zeros of the polynomial be alpha and beta. Let the zeros of the polynomials be alpha and beta. Now there is a relation between coefficients and zeros of the polynomial. One thing is called sum of the zeros. Sum of the zeros, that is nothing but what? Sum of the zeros is what? What are the zeros? Alpha and beta. Sum of the zero is alpha plus beta. Okay. Next is called product of the zeros. That is what? Product of the zeros. You have to remember this throughout your career or throughout your student life where you do mathematics, because it will be useful wherever you want. Okay. So many places it will be useful. Zeros of the polynomial, sum of the zeros, product of the zeros, all these things will be useful even when you study for JEE, all these things. So product of the zeros, that is product of the zero is what? Alpha and beta is product, means alpha into beta. Is it done? That's all? No. The sum of the zeros is nothing but equal to, that is coefficient of x minus coefficient of x by coefficient of x square minus b by a. It is equal to what? Minus b by a. Now product of the zeros, product of the zero means that is equal to c by a. It is equal to what? C by a. It is equal to what? C by a. Product of the zero is constant divided by coefficient of x square, that is equal to what? C by a. This you have to remember. Okay, this is highly important. Sum of the zeros and product of the zeros. Sum of the zeros is equal to what? Minus b by a. Product of the zeros is equal to what? C by a. This will little change, it will vary little when it comes to cubic polynomial. This we are talking about quadratic polynomial, that is ax square plus bx plus c. Now, for this let us take one particular example and try to establish the relation between coefficients and zeros of the polynomial. Let us take a particular example and let us try to see this. Okay. Now, if I take a particular example, let me take this one. Let me take x square plus 4x instead of x square plus 4x, let me take x square plus 7x plus 12, x square plus 7x plus 12. First I have to do what? I have to factorize it and find the zeros of the polynomial. P of x is given like this. P of x is given like this. So, P of x can be written as what? P of x can be written as x square plus 4x plus 3x plus 12. That is what? Splitting the middle term, quadratic equation, that is what you do, splitting the middle term. So, if I take x common here, x into x plus 4, here also it will be x plus 4 only inside. So, if here I have to take what? 3 common, 3 into x plus 4. This becomes what? X plus 4 into x plus 3. X plus 4 into x plus 3. This is P of x. So, here x becomes what? X is equal to x plus 4. If I equate it to 0, this will become, see here, if I equate x to x plus 4 to 0, because if you have to find the 0, you have to equate it to 0, that is x plus 4. So, x minus x is equal to minus 4. If I equate x plus 3 to 0, I will get it as what? X is equal to minus 3. So, this x is equal to minus 4, let me take it as alpha, x is equal to, x is equal to minus 4, let me take it as alpha. I can take any of them. I can take minus 4 and minus 3 as alpha, or minus 4 and minus 3 as beta. If I take this as alpha, this will be beta. Now, we have to find what? We have to find what? We have to find sum of the zeros. Sum of zeros. Sum of zeros. Sum of zeros is what? Sum of zeros is what? It is nothing but alpha plus beta. Alpha plus beta is equal to what? Alpha plus beta is what? Minus 4 minus 3. This is minus 4 plus minus 3, that is nothing but minus 3 itself. I will get minus 7. Product of the zeros. Product of zeros. Product of zeros is what, friends? Product of 0 is alpha into beta, that is nothing but what? Minus 4 into minus 3, that is 4 3s are 12, minus into minus, I will get it as 12. This is what we got directly. Now, if I use the same thing, sum of the zeros is nothing but equal to what? Minus b by a. If I use the formula, that is minus b by a. Minus b is what? B is 7. So, minus b is minus 7 and a is equal to what? 1. So, the answer is nothing but 7. Okay. So, sum of the zeros. So, if you see, if I write it as equation 1 and if I write it as equation 3, if you look at equation 1 and equation 3, you are getting the value as minus 7 also, there also you are getting 7. So, sum of the zeros alpha plus beta is nothing but equal to what? Minus b by a. That is correct statement. That is correct. So, we established that relation. Now, if I look at the product of the zeros, if I look at product of the zeros, okay, if I look at product of the zeros, that is nothing but what? C by a. Here C is what, friends? C is equal to 12. 12 by 1, that is equal to what? 12 itself. This will become equation 4. If you look at this, let this be equation 2. If you observe equation 2 and equation 4, what you are getting? 12 itself as the answer. So, here product of the zeros alpha beta is nothing but equal to C by a. Hence, we have proved that sum of the 0 is alpha plus beta is minus b by a and product of the zeros alpha beta is C by a. Okay. Hence, we have established this relation. Now, okay, based on this, we will solve some questions in the next exercise, that is exercise 2.2. But before that, I will give you one question as homework. Please try to solve that question. 2x square plus 3 plus let me take this equation, 2x square plus 4x plus 8. Okay, or instead of that, let us take simple equation, x square plus 4x plus 4. Okay, P of x is given as x square plus 4x plus 4, x square plus 4x plus 4. For this, first you have to find the zeros of the polynomial, then find alpha, that is alpha and beta, you will get it. Then find sum of the zeros using direct method, alpha plus beta, then product of the zeros, that is alpha into beta, then using the formula, that is relation between coefficient and zeros of the polynomial, that is alpha plus beta is equal to minus b by a, then alpha into beta is equal to c by a, and see whether they are coming equal. Definitely it should come equal. Please try this method. This is the homework that I have given. Okay, I will wind up now. Let's meet in the next session where we will completely solving exercise 2.2 friends. Okay, I hope it is clear. Okay, thank you for watching the session. Those who haven't watched previous session, please watch that also. Then your basics will become crystal clear. Let's wind up now. In this class, we learned one very important concept, that is geometrical meaning of the zeros of the polynomial. Okay, let's wind up now. Thank you friends.